All right, good morning. Welcome to week 6. This morning I discovered a happy surprise, which is I've been thinking all this class that I've been somehow about half an hour or 45 minutes behind schedule with all my lectures. And no, apparently I've been about 45 minutes ahead. So I couldn't figure out a while ago why I had to do this extra video for NumPy, and apparently in the past I have always been behind, and now by virtue of doing that extra video, I'm actually ahead of schedule. So in previous invocations of this course, we talked about string handling during the first hour and a half or so of week 6, and then an introduction to classes during the last lecture. But lucky for us, because we have been working hard and gotten ahead of schedule, what's going to happen is I'll talk about classes today, just to give you a flavor of how classes work and how you go about creating and using classes in Python. And then all we'll have left on Thursday is the quiz. So I won't be doing any more talking on Thursday. We'll just, show up, do the quiz, and then next week we will have the group presentations. Okay? Let me say a little bit about the group presentations. I posted information about the presentations over the last few days. And the main thing in your group presentation is to be very clear in your presentation about what your vision for your product is. That is, what the pain point is for the customer that you're trying to serve, and how your product is going to resolve that problem for your customer. Most of the credit for the presentation will just be the general professionalism of the presentation. We want to see that you've actually practiced this thing more than half a time, and that your transitions from one person to the next are reasonably well coordinated and so on. I'm not going to expect you to wear business attire. You can if you like, but I'm not going to grade you on that. And then lastly, it is important that each person in the group do approximately an equal amount of the presentation. It doesn't have to be, you don't have to time that down to the 15-second interval or whatever. What we want to avoid is a scenario where one person does half the presentation and the other 3 people do the other half. I've seen that a few times, and it's not a good look if you're a group trying to sell an idea to a customer. Any questions about that? Alrighty, so let us get into taking a look at how you define and use classes in Python, including why you should care. So the idea of a class is to create a higher level data type that directly represents some key concept that you want in your program. So if you're developing a human resources application, you might want to directly represent employees and managers and directors. If you're developing a finance-related application, you might want to directly represent stocks and bonds and real estate contracts and things of that kind. It's much cleaner at the application level to be able to work directly with the high-level objects that you're conceptualizing about, instead of having to devote all your energy to thinking, well, okay, I really want to represent a stock. How do I take this idea of a stock and shove that down into ints and floats and lists and sets and so forth? The traditional old-style top-down programming was sort of all about that approach, taking the high-level concept that you wanted to think about and devoting all of your energy to pushing all that down to the level that the computer could actually deal with. Here we're trying to go the other way. We're trying to go from the level that the computer can actually deal with, ints and floats and bools and strs and so forth, and pull that up to create a data type that we can use and think about at a much higher conceptual level. Make sense? Cool, I'm glad you think so. Very good. Okay, so what a class does in Python is to combine together or package together as a unit the data attributes for the class that keep track of the current state or the current knowledge of the objects that you're trying to create. Secondly, there are methods that provide the behavior of objects of the class. That is, these are the functions that you can request be called to do things. Like for a stock, you can request to fetch the current price or change the current price or perhaps ask for the return relative to yesterday's price, these kinds of things. As a supporting mechanism, you may find that your class that you're developing would benefit from making use of some slightly lower level classes internally. You can think of these as being like helper classes in the way that you might define a helper function to do the picky repetitive work of some other top level function that you're defining. But most of the name of the game with classes is data attributes for keeping track of values and methods, functions for performing tasks. All right? Now, one of the goals, well, okay, one of the goals of object-oriented programming, but I'm just going to say one of the goals of programming, period, is that when you introduce an object into your program, it should always be in a valid state. That is, it should always contain valid data. It should not just be uninitialized and contain garbage. Actually, in Python, that's not really a problem because we can't even introduce a variable in Python without tying that variable to some specific value. But in other languages that you may have encountered, like Java and C and C++ and so on, it is possible to just create a variable whose initial value is undefined. And if you then access that variable, you just get whatever random garbage is sitting in memory at the point where that variable was created. Okay, so all of the methods that provide the behavior of your class automatically in Python receive a reference to the current object, and the name that people use for that is self. Now that's not actually defined in the language. You could choose some other name, but essentially everybody uses self. And in order to make sure that an object that you introduce is properly declared, you should define what's loosely called a constructor. In Python, this is the underscore underscore init underscore underscore. That is the dunder underscore the dunder underscore the dunder init function. That function automatically gets called to initialize all of the internal state of whatever the object is that you're trying to create. Okay, so you definitely are going to want to have an init method for every class that you create. Internally within init, the first argument is going to be this thing self, which is a reference to the current object that's being created. Another method that you are essentially always going to want to create, there's never any reason not to create this, is the dunderStir method, which is the method that gets invoked, for example, by the print function to convert the internal low-level data within your class to a human-readable representation. And when you call, for example, the stir conversion function in your code, internally what that does is to invoke this dunderStir method within the class. So let's take a look at a concrete example to to add some actuality to that babbling theory I said on 24, let's imagine that we want to represent employee objects in our program. We first need to think about, well, what information does an employee object need to know about itself? And for our purposes, we're going to say, well, clearly every employee has to have a name. Every employee has to know its own name. Also, every employee, the way we're going to organize our employees, is going to have an hourly pay rate. And typically in a company, when an employee is hired, they're given an employee ID number so that they can be differentiated from all of the other employees in the company. This way, if you have 9 people named David Jones, you can use the employee ID numbers to tell all of them apart from each other. Okay? So we're going to have an ID number as well as a name and an hourly rate. To represent this in code, now that we have talked about what each employee is going to have to know about itself, we also want to talk about what we want each employee to be able to do as far as interacting with the program. We are going to want to be able to create employee objects in the sense of hiring a new employee for our company. We're going to want to be able to represent each employee object as a string so that we can see the representation, the human readable representation of the employee on our screen. And let's suppose that we want to give our employee a raise every so often. There's a lot more behaviors that we are really going to want our employees to be able to do, but this is enough to at least demonstrate some code. So far, so good? Okay. So, we define our class employee with the keyword class and the name of the class and a colon. So in that sense, it's very much like defining a function where you start with def and then the function name, or an if where you start with if and then the expression and a colon. Then, indented one level underneath that, you specify the methods that you want the object to be able to respond to. And in particular, we're always going to start out with an init method and a stir method. Now, what should happen when we initialize an employee? That is, what should happen when we create an employee object in our program? Well, what should happen is that employee's name and ID number and rate need to be passed into this initialization function and be stored internally within the current object. Okay, so init is a function. The first argument of any class method is always going to be self, so just take that for granted. And by the way, if you write classes, one of the first mistakes that you're going to make is to forget to say self at the beginning of every method you define. Okay, so you got to say self to begin with, and then we'll have name, ID, and rate. And internally within this current employee object that we're building, we're going to say I want this employee's name, that is self._name, to be the name value that was passed in as an argument to init. Likewise, I want this current employee's ID number to be the ID that was passed in, and I want this employee's hourly rate to be the rate that was passed in. There's no requirement to use these names _name, _ID, _rate. It's just that you want to choose sort of self-documenting names to store the information that an object contains, to store the data that an object contains. And the reason for these underscores is the underscore is intended to inform other programmers using your class that this name data member should be treated as private, and you should not, as some other programmer using employees, directly modify the name. You should instead restrain yourself and use the the methods that are defined to communicate with the employee class. All right, well, in our case, that's all that's involved in initializing a current employee object. We just say, for this new employee object that we're creating, I want to save the current employee's name, ID, and rate using the arguments name, ID, and rate that were passed in when I created the employee object. Next, I want to have a string conversion function that will represent an employee object in string form so that I could, for example, print an employee. And yes?
What if I want any other variables to be a part of employee class, but I don't want to define it in the constructor? So can I have such variables?
Okay, now, okay, so that's a really good question. Do you want the variables, so you want to ask, can I have other variables for the class?
Self.job or something like that, but not a part of the constructor.
But not a part of the constructor. Okay. It is possible to have variables that belong to the class as a whole, as opposed to variables that belong to an individual employee object within the class. And let me catch up to your question, because we are going to talk about that. Okay? So yes, the short answer is yes, you can have variables within the class that belong to the class overall that that do not need to be set within the constructor. Okay, so we do have a way of initializing an employee object, and now we want a way of converting that employee object into a string representation. We're going to do this in a fairly straightforward way. We're going to create a string looking like ID colon space, and then the ID number. Now the ID number presumably is going to be an integer, although there's no there's no requirement anywhere in the code that the ID number be an integer. We're just going to probably adopt that as a convention. So we're going to convert the ID number into a string. Plus, of course, is concatenation. Then we're going to display name and the user's name, which we will assume is a string. Then we're going to display salary and the user's salary. And notice that we're using our good old format function here to specify that I only want to represent the rate with 2 digits after the decimal point. Okay, so if I have given somebody a fractional raise such that their actual rate is out to 6 decimal places, when I display that rate, I only want to see the first 2 decimal places. Okay, and then finally the third. Sorry, I've been teaching these same concepts in C++, and so I keep wanting to use C++ terminology. Okay, so the other method that we want to define initially for our employee class is a method that will allow us to give a raise to an employee. And we're going to pass in that raise value as a percent value. So let's suppose that we want to give the user a 10% raise. We would pass in a 10 as the percent raise. That means that the actual rate should be adjusted to itself times 1 plus 10 over 100. So in other words, the user's current rate should be adjusted to itself times 1.1. Make sense? Yes.
For the second method, which is when you're saying the method, over there self is the self from the method above, or is it?
Okay, self. Okay, excellent. Self is the current object, and self in the dunder-stir method. Come here. There we go. So self in the dunder-stir method is this parameter self. whereas self up in the dunder init method is that parameter self. You could confuse yourself and everybody reading your code by calling that first parameter self up here and me down here and myself down here. You could use different parameter names for that first parameter for each method, but that would be crazy.
I was wondering, if that is the case, how would it know to return self under name? Because the scope of that is only the method above.
Okay. The first parameter to each method is the parameter that's going to be used within that method to refer to the current object. So within the dunder init method, self dot underscore name means the current objects, the current employees underscore name data attribute. Sorry, I keep wanting to say data member, but that's not the right term. Data attribute. Okay, so in the init function, self dot underscore name is the current employee objects underscore name data attribute. Down here in stir, since self is the first parameter to the stir method, the dunder stir method, then self dot underscore name here means the underscore name data attribute of the current employee object. So these selves are not the same as each other in the same sense that if I say define f1 of x to be return x squared, and I define f2 of x to be, and I define f2 of x to be return x over 2, this x and this x are not the same x. They're just labels that I'm choosing to use within this function to represent the parameter. Similarly, here, this self is not the same as this, well, let me back up. This self here is the name that I'm choosing to use within the dunder init function to represent the current object. This self in dunder stir is the name that I'm choosing to use within dunder stir to represent the current object. But there is not some global self everywhere. It's just when I call this method, the first argument that gets passed in is a reference to the current employee object. And I'm choosing, because I want to follow the convention everybody follows, I'm choosing internally within this method to call that thing self. And then when I call dunder stir, the first argument that I get is a reference to the current employee object. And I'm choosing to follow the convention of naming that thing self within that method definition. But it's just a parameter name. It's just a parameter name. And the only thing that's really the same about this self versus this self versus this self down here for get raise is that it's the name. It happens to be the name that I chose for the first argument, for the first parameter. Does that help? Any other questions? Okay. I could have called this one A and this one B and this one abracadabra. It doesn't matter what I choose. Okay, so now that I have defined my employee class and I have defined the three methods, Within the init method, I have also set up the 3 data attributes that I want each employee object to have. Now I can test my employee class by creating an employee object and using that employee object. The way I create an employee object is to give the name of the class as though that thing were a function and pass parameters or pass argument values to that class. This is going to invoke the dunder init function for the employee class. And the first argument that's going to get passed into dunder init is a reference to the current employee object that's being created. That's going to be self. I don't have to explicitly pass that. That gets passed implicitly, automatically. So the first argument passed into the init function, as I said, is a reference to the current object. But the subsequent 3 arguments that I'm passing in are the string John, the integer 1, and the float 60.50. So within the init function, John gets used as this current employee object's underscore name data attribute. 1 gets used as underscore ID, and 60.5 gets used as underscore rate. Okay? Now, I can explicitly call the dunder stir method by using the stir function. I can say stir John, and that will generate for me a string representation of this employee whose variable name is John. It turns out that the print it turns out that the print function will do that for me automatically. So I can just say print John, and the effect is as though I had said print stir John. And let me emphasize that because it's worth keeping in mind. When I say print 5 true 0.1234 hello, the print function is in effect really doing for me print stir 5 stir true stir 0.1234 stir hello. Okay, so stir 5, stir of the int 5, gives me a string back, quote 5 quote, and stir true gives me a string back, quote capital T little RUE quote, and likewise stir of 0.1234 gives me quote 0.1234 quote. Now converting a stir to a stir is easy. There's nothing to do. All right, so it is, when you call print, it is as though stir got called automatically on each argument, on each positional argument. All right, here we're creating another employee object. We're using ed as the reference to this new employee object that we're creating. The underscore name data attribute is ed, the underscore ID is 2, and the underscore rate is 72.25. So when I print ed, that's exactly what I get. Let me run this to see what we actually get. Here is the program, or here is the code file with the class that we saw in our notes defined in the top half of this code file, and then this testing code. If dunder name equals dunder main, we're going to create John and display John twice. Then we're going to create ed and display ed once. Then we're going to give ed a raise and redisplay ed. Okay, we're giving ed a 10% raise, which means that ed's rate is going to be multiplied by 1.1. So ed's rate is going to become, now can I do this arithmetic in my head, 70 9 point. No, I can't. 475. So Ed's rate is going to become 79.475. Realistically, we'll just round that up to 79.48. And in fact, when I display Ed with a rate to 2 decimal points, the displaying will round the 5 up to the next higher integer. All right, so let me run this guy now. And there we go. Okay, so we created John and displayed John twice. We created Ed and displayed Ed once. Then we gave Ed a 10% raise and displayed Ed a second time. And we have therefore exercised all 3 of our methods. We have used init twice for John and for Ed. We've used stir several times. We've printed John twice and Ed twice. And then we've given Ed a raise. And the notation for invoking a method is what we are already familiar with things like lists and stirs and dictionaries and so on. We say object dot and then the method name and the argument. And a question?
So just a trivial question. In what case do we really have to enforce if dollar name is equals to dollar name? Because I could technically execute the same class without that if block, right?
Right. Now, okay, excellent question. The reason that I chose to put this if in here is because my goal here, developing this employee class, is for other people in other code files to import my class and use it. And if I did not have this if test in here, then every time somebody else imported my employee class module, they would get this mysterious output for John twice and Ed twice, which they're not going to want. They want to be able to create and use their own employees. They don't want to see this stuff about John and Ed. Okay? Any other questions so far? Alrighty. All right, so each individual employee object has its own underscore name, underscore ID, and underscore rate data attributes. We haven't provided any way of accessing those individual values or modifying those individual values. So it's going to be tempting for somebody using our employee class to just go in and directly interact with those data attributes. We would prefer, by convention, to have people using our class respect those internal data attributes as private. And I was going to say, well, I'll say it anyway. The conventional Python convention is to stick an underscore in the beginning of the name of each data attribute that you want to not have directly accessed. This is not enforced by the system in any way. It's a mark that you want these data attributes to be respected and treated as though they were private. It's sort of like you know, it's sort of like having a little sign next to your door on your house saying, no, I've forgotten the word. Oh, I'm getting very ancient. No solicitors. You know, no solicitors. It's not enforced. It's just a really strong suggestion that you don't want people knocking on your door and trying to sell you vacuum cleaners and stuff. All right. So once I have the employee class defined, I can write code that does things like this, comparing one object's rate to another object's rate by just directly going in and accessing the .rate data attribute of John and the .rate attribute of Ed. All right, so if John's rate is greater than Ed's rate, I can display that John makes more than Ed by directly accessing the name attributes. But this is exactly the kind of behavior that we're trying not to. We're by putting underscores on these data attributes, we're trying to tell other programmers, hey, other programmers, please don't do this. Instead, what we will make available to other programmers to use is some set and get functions that will make it relatively easy for other programmers to invoke these set and get methods to interact with the underlying data attributes rather than going in and directly messing with them. Now, so we're going to create set and get methods for our name, our ID number, and our rate. However, we're not going to create a set method for the ID number because once an employee has been hired, their ID is never going to change. Okay, now their rate will change. Hopefully it will increase. There is unfortunately no keyword that we can use to specify that it only increases, but hopefully the rate will be increasing. People's names can change. You know, people get married, people just arbitrarily decide to change their name to Meta World Peace or whatever. Are you familiar with the basketball player Meta World Peace? Not his original name. Anyway, you know, so people can change their names, people's rates can change, but the ID number should stay fixed. So here is what we're going to do. We're going to define two set functions for setting the name and setting the rate, which will modify the underscore name and underscore rate data attributes. We're also going to define three get methods for getting the current name of the employee, getting the ID, and getting the rate of the employee. Now, hopefully, people using the class will make use of these set and get methods rather than directly going in and messing around with the underscore name, underscore rate, underscore ID. Why should we care? Well, there are two reasons why we should care. One reason that we should care is if the user of your class just goes right inside to the internals of your class and starts messing around with the data attributes, if your class is very sophisticated and doing a lot of allocation of objects with you know, references to references to references and so on, it's very likely that an unskilled developer using your class is going to cause mysterious behavior and crashes by directly interacting with your data attributes rather than using your interface functions. All right, so there's that aspect of, you know, in effect, protecting the user from him or herself, the application programmer. The second thing is that we may later, at some future time, decide that we want to change the internal details of how our employee object is represented. Specifically, in this case, we have an employee name, and that's it. But we might prefer, you know, our human resources department might come to us at some point and say, you know, I really gotta have first name, last name, middle name, prefix, suffix. I've really got to have all 5 of those things separate. You know, I want to have, you know, Dr. Albert W. McGillicuddy Jr. I really want to be able to represent all of that stuff as separate pieces. And so now you as the developer of the employee class are going to have to go in and say, well, I can't just have one name anymore. I have to have prefix, first name, middle name, last name, suffix. If the user, the application developer making use of your employee classes, has been calling getName, Well, the behavior of getName for them won't change because you can modify the implementation of getName so that instead of just saying return self.name, you say return self.prefix plus space plus self.firstname plus space plus self.middlename plus space and so on. So you can modify the implementation of getName to reflect this newer, more complex representation of employees, and people who've been calling the getName interface function won't notice that anything has changed. On the other hand, if people are directly going in and accessing the _name attribute, and you release your new and improved employee class, well, their code is going to break now because your employee class no longer has anything called _name. It has _prefix and _first name and _middle name and _last name and _suffix, but it doesn't have anything called _name anymore. So your release of an improved version means their application won't run anymore. Okay, so in Python, all of this is voluntary, but we really want to emphasize to Python programmers generally that you should not go mucking around with the internals of some other developer's class. You should instead be respectful and use the defined interface methods for accessing and modifying the information within the object that you want to access and modify. Question?
I was wondering, does that mean that the good convention would be for the get function to return a list that can then expand, but the first element of the list would always be the same? Because in the example that you gave, we changed the output type, it will still break the code.
Okay, now, let's think about that. Wouldn't you, as someone trying to use the employee class, all right. So you look at all these kinds of questions from the perspective of the developer of the class and the perspective of the user of the class. Now, I'm a user of the class. I'm trained, but not exceptionally well trained. I think it's going to be puzzling for me to say get name and get back a list of something. I just want to be able to call get name and get a string. So you as a developer, maybe you talk to me, maybe you don't, but maybe you just figure out, hey, my user is stupid, I'm just going to give back a string. And then you have separate methods for get prefix, get suffix, get first name, get last name. And you just add. See, you never, well, I try never to use the word never. You almost never break anybody's application by providing more methods that they haven't called yet. So you want to, the existing methods that people are already using, you want to leave those and behaving as pretty close to how they originally behaved as you can. But then you can always add more methods that provide additional behavior. And if you look at languages themselves, at how languages developed and evolve, and how libraries evolve, they will often have these documents about what they plan to do in the future, and they will start labeling certain things as deprecated, meaning that a decade from now that feature might disappear. And you as a class developer want to behave the same way. You might want to publish a warning that, hey, a few releases from now, I might eliminate this getName method, but for now, I'm going to leave it to give you time to transition. And so you give people a decade to transition, and none of them will. So then you remove the getName method, and all their programs crash, and you say, I warned you a decade ago. Other questions? Okay. Okay, so now, rather than directly accessing the rate data attribute and the name data attribute, I can still perform the same test. I can compare John's hourly rate to Ed's hourly rate by calling the get rate methods instead of directly accessing underscore rate. Okay, so the variables that we've used within each employee object are called instance variables. All right, so underscore name, underscore ID, and underscore rate are referred to as instance variables, and what that means is that each instance of an employee object has its own internal copy of those variables. All right, so John has an underscore name, underscore ID, underscore rate attributes, data attributes. Ed also has underscore name, underscore ID, and underscore rate, and of course Ed's underscore name, underscore ID, and underscore rate are different from John's. It is possible to have a variable, and now I'm finally coming to answer the question about can you have a variable that's not inside the init. It is possible to have a variable that belongs to the entire class. And this is called a class variable. Why would we ever want such a thing? Well, let's suppose that in addition to each individual instance of an employee having its own name, ID, and rate, we also want to be able to query the employee class as a whole and say, you know, hey, employee class, how many employees currently exist? Okay, so we want to be able to inquire of the employee class, in effect, how many times has the underscore init function been called? And here's an example of that. I just define a data attribute outside of my method definitions, and then to access that data attribute, instead of using self and dot and the data attribute, I say class and dot and the data attribute. So here I'm initializing that when the program first starts running, the number created for employees is 0. Then each time the init function gets invoked to create a new employee object, I am going to increase the number of employee objects created by 1. Make sense? So now I can find out how many employees have ever been created by accessing that variable, employee.numCreated. It turns out also that you can ask for a class variable by applying that the dot to an individual employee. All right. So even though numCreated belongs to the class as a whole, it's considered to belong to each individual instance of an employee as well. All right. So employee.numCreated and John.numCreated will give me back the same information about how many employee objects have ever been created. So far, so good. We can get into the same argument about, well, you know, do we want users, do we want application developers to directly access this numCreated variable? And probably not, actually. So probably we should have created numCreated with an underscore in front of its name, and then we could have defined a method that returns the number created. So we can fine-tune this. Now, another thing that classes allow us to do is to use something called inheritance. And what inheritance does, sorry, I need to get another cough drop in place before I can't talk anymore. What inheritance does is to allow you to describe and is a kind of relationship between classes. So we have already got our employee class defined, and now human resources comes to us and says, well, you know what, we've, sure, I mean, everybody at the company is an employee, but some of these employees are managers, and we would like to be able to differentiate the additional responsibilities and knowledge that managers have in addition to what employees already have. Now, in a non-object-oriented language, that would be a real pain. You would have to say, all right, well, okay, so I'm going to make a copy of all my employee code. I'm going to call that thing a manager, and then I'm going to add some code so that managers do the same stuff as employees do, but they also can do more stuff, and they know more stuff. And now what's the problem? Well, now, every time an employee needs a new behavior or a new piece of knowledge, a new piece of data attribute, I have to remember, well, okay, not only do I have to add it in the employee class, but I also have to go over and add the same thing in the manager class. Now those dratted people in human resources come to me and say, well, but I've also got directors. And directors are like managers, but they have even more knowledge and even more responsibility. So now, oh God, I've got manager as a copy of employee with some additional stuff, and director is a copy of manager with some additional stuff. And if I have to change employee, I have to also remember to make the exact same identical change to manager and to director. And this is why software typically doesn't work. So to alleviate this problem, you can directly, in an object-oriented language, say that a manager is a kind of employee, and then you only have to write the little bit of incremental stuff that a manager has to be able to know and has to be able to do that the employees don't have to know or do. Then, if you need to make some changes to how employees are implemented, you know, you need to give employees more detailed knowledge or more behaviors, the manager will automatically get that stuff without you having to change any code. So it's, from an implementation standpoint, it's a really good way of reducing opportunity for copy and modify bugs, and therefore just reducing the overall amount of code that you have to write. All right, so the way that you do inheritance in Python is, now this is a new file. This is my manager class file. It's called manager.py. And what I'm going to do is I'm going to import my employee class module into my manager class module with the abbreviation emp. And then to say that a manager is a kind of emp, I say class manager, and then instead of giving my colon immediately, in parentheses I indicate the underlying data type of the thing that a manager is a kind of. So that line, class manager parentheses emp.employee, says that a manager is a kind of employee. Therefore, if I declare a manager object, automatically I can say, let's suppose that Susan is my manager object. I can say Susan.getName, Susan.getID, Susan.getRate, and all of those methods are already available in the underlying employee object, and so I can just use them immediately without having to rewrite any code. I am going to need a dunder init function and a dunder stir function for my manager class, my derived class. Notice that for the manager, in addition to having a name, an ID number, and a rate, the manager is also going to have a budget to keep track of. Now, the name, the ID number, and the rate, those three pieces of information need to be passed down somehow into the underlying employee init method. And that's what super does here. It says, okay, I want to invoke the super classes done under a init function and pass the name, the ID, and the rate into that done under init function. So that's going to invoke the employee classes done under init function to set up the underscore name, underscore ID, and underscore rate data attributes with the arguments that have been passed in. And then, back at my manager level, all I have left to do is to create an instance variable called underscore budget. That's the only incremental data attribute that the manager requires, and it will contain the value of the budget argument that was passed in. Okay, so to initialize a manager, I first need to initialize the employee within the manager, and then do whatever incremental initialization stuff the manager itself requires. Super is something that people sometimes get puzzled over, and I do, despite that I've been using inheritance since around 1990. If you think in terms of how normal people use these words, something that's super sounds like it must be bigger and better than something that's not super, doesn't it? But actually, no. We're using the term super in a set theory sense here. The superset, the super class, actually has less knowledge and less behavior than the outer class that it's derived from. So the super class here is the employee class, and the employee class only knows about underscore name, underscore ID, and underscore rate, and it has about 8 methods. The employee class, which is the more knowing, more behaving class, also has a budget to keep track of and to worry about and to offer access to. Nevertheless, employee is the superclass of manager, and so to invoke one of the employee class's methods, you say super parentheses dot, and that gives you access to the superclass. Yeah.
Is this because employee can have a bunch of other variables, but when we get the child manager, we only define name, ID, and rate?
I'm sorry?
So in this case, employee only has 3 variables.
Yeah.
But we might think of a case where employee has 100 variables, and manager only uses name, ID, and rate.
Okay, if we're using inheritance, we're saying that a manager is a kind of employee. It inherits everything. So the manager has to be at least as knowledgeable and at least as capable of doing things as the employee.
So then the employee is a child of manager?
See, here's where people use different terminologies, but no, actually, employee is a parent of manager. And so Strustrup, who designed C++, thought, wow, this is confusing everybody that I talk to, that the superclass and the parent class actually has less knowledge and less ability than the child class or the subclass. So his workaround, this is Python, so you're not allowed to know this, but his workaround was to talk about base classes and derived classes. And it's clear to everybody that, okay, so the base class is the thing at the bottom of the tree. It depends on how you look at your tree. And the derived class has more stuff. But in other languages, the terminology parent and child classes is used, or the terminology super and subclass is used. And Python uses super and subclass. Okay, so a manager is a kind of employee. A manager also keeps track of a budget, And so as methods, the manager class has a set budget and a get budget method. Otherwise, a manager can do everything that an employee can do. We can set the name, we can get the name, we can get the ID, we can set the rate, we can get the rate, we can give a raise. Everything an employee can do, we can also do with a manager. Okay, and so here's a manager named Ann, ID 3, rate 88.75, and budget of $750,000. Okay, so that's all I had to discuss, just to introduce you to this idea of classes. Any questions? All right, well, we're a bit early, but that is the end of everything I wanted to tell you about. So we'll go ahead and wrap up the class here. And the quiz will start, let's say 5 minutes after. Okay, so let's say the quiz is going to start at 10:35. So if you can't get here, like right at 10:30 on Thursday, you'll have a few minutes before the quiz will start. I think we're still finishing grading some of the quiz 2s. My impression is that more people had trouble on quiz 2 than did on quiz 1. That doesn't mean that grades are going to be worse, because we'll just move the curve a bit. Your grade might be worse, or your grade might be better. But on average, it doesn't mean that grades are going to be worse. So I may decide to give you a little more time for quiz 3. I'll make that decision either today or tomorrow. All right, so I will see you on Thursday. Does anybody have any questions about projects or homework or anything at this point? You had a question? Or? Oh, I think I announced that, but maybe I didn't. What's on quiz 3 is NumPy, pandas, and regular expressions. Did anybody remember seeing that announcement, or have I? Okay, I will announce that as soon as the class is done. Does anybody else have questions? Okay, so I will see you on Thursday.